Hum-de-dum-de-dum. Okay. All right. Well, why don't we do that just now as it came up? So everybody, if you have questions about the standard curve graph excitement, kind of put your thoughts together, and we'll go over those in a little bit. So I just had a question about table and figure legends. So I have a very particular format. If you look at any paper, you'll see the format that they take. And really, it's a standalone description of that thing, right, that you have in your manuscript or your lab report or whatever. So an example would be table 1, distributions of raw data and chi-square. Yeah, if I could type. I don't know. I'm just making this up as I go along. So that would be your, essentially you have a like a title, which is a sentence which describes what it is that the reader is looking at. Then you might have, I don't know, kind of making this up as I go along. A little bit of a description of what you did. Between female, double, hetero. Yeah, that'll do. So the idea of a legend, so not I Am Legend, even though that's a very cool book. Cool film too. Book is a lot better though. So the idea, like the gold standard of figure legends and table legends, is if you take that table and its table legend, and you take that out of your lab report and you give it to me, I will be able to understand what it is that I'm looking at and how you did it. Same with a graph or an image or any of that jazz, right? Do I have this up? Let's give you an example. Do I actually have that? Hmm. Hang on a sec, whoever that was. Just open it. Yes. Yeah, that's exactly it. And it's really so that you don't have to constantly refer back to the text to be able to interpret that figure, because if you have like a standard paper or even textbook, right, those figures are more or less kind of where the text is that describes them, but it's not exactly there. And so the figure legend is like a little, kind of like a key almost, that helps you understand what it is that you're looking at, right? So this is like what's called a micropub, which just got accepted. Yay, which is super neat. And all right, come on, down you get. There we go. And so here's a bunch of couple of graphs, right? And so these are different genotypes. This is a particular phenotype that's being scored, and this is the figure legend. And so the first sentence is a basic description of what's going on, so that whoever's reading it can go, "Oh, that's cool." And then each graph or figure is described in turn, right? We've got A is by RNAi, B is by mutation. Then we've got a little bit of how that was scored. You know, one was using a particular marker, one was another. This is what the error bars are, their standard deviation. These are what the data labels are. This is what these things mean up here. So you could take that out in its entirety and you would be able to go, oh, now understand what is going on without any of the text there. Now the text is really useful because, you know, all this stuff down here is basically how we kind of interpret that, right? How we describe it, how we give extra insight into what these particular graphs show. But that's like a kind of like the full picture. Essentially, this is a key or a snapshot that will help you understand it. And that's why they're so very important too. Because if you look at, for example, where are we at? This paper. So table legend in this case is pretty simple. It's just a description of what these things are. But anyway, we're down here. Doom, doom, doom. All right, this is kind of crazy, right? This whole bit of text is a figure legend describing these figures, right? So there's a bunch of pictures, like what are they, what genotypes are they, et cetera, et cetera. But we might not be talking about that stuff in this page. It might be, well, there's figure 1A and B up here, figure 1F. We might be referring to figure 1 still down on the second page. Right, so if we wanted to understand this fully, it's kind of hard jumping back and forth between the text and the figures. In fact, like the raw manuscripts have the figures at the end typically, and they're an absolute pain in the backside to read because they're not together, right? So this just makes it easier for your readers to understand what's going on. Where are we at? Okay. How do I stop sharing my... Oh, there we go. Okay. Did that help? Probably a little bit more detail than you really needed, but it doesn't hurt to show you it in real life as well. Okay. So, questions about the assignment tonight. All right. I know there's at least a couple of you who've emailed me separately, and I'd prefer, if possible, to answer these questions to you all at the same time. I'm just making sure there's at least one who hasn't, and I'll be able to reply to her separately. But there's a couple here that did ask me questions. So ask me those questions. If you're more than welcome to type it in the chat. Truly, you don't have to think that you figured it out. I'm more than happy to spend time going over it because that's one of the big things that we have to talk about here. Let me just double check. And the reason why I didn't reply to your email directly was not because I was ignoring you, it's because I wanted to do this together. Okay, well I can answer your question. Okay, so let me just double check, make sure I took a picture of the last thing. And as someone just did, if you have questions, you are more than welcome to send me those questions privately, right? So if you go down to the chat box and you hit the drop-down menu, well, I can't see me because I am me, right? But you can send me a message personally, like privately, right? So other people don't have to see it. And I get that as well, you know, it's totally fine. It's not an issue whatsoever. So, actually, I learned something really cool from this lab. I didn't realize that you could draw a line of best fit as a log line, which is pretty cool. Okay, so got distance in centimeter, size in base pairs up here, and I'm going to do this as a log scale because you can either do as a log scale on the X. So this is log. Oh, yeah, that's cool. Or you can do it as normal linear scale for both. Okay, give me a second. That second question, I'll get to that in just a moment. Where is that? But then you can use an exponential line instead, and that should be straight. I don't know if can't remember who it was that pointed that out, but that was a cool thing to learn. Anyway, so essentially what you do is you take each, and this may answer the second question that I just got. You basically are going to draw up a let's say this is 10,000, 6,000, 1,500. All right. So this is like a picture of the gel, right? Essentially, it's obviously a simplified version. And so what you need to do is measure that distance, and you know what that size is. And this also applies for the Edvitech marker. It's just the sizes of the bands will be different. So if you want to know what those sizes are, it's in your handout. Or if you go to the Blackboard page for that lab, you'll also have a standalone picture of the Edvitech sizes. Let's see. Where is that at? Ah, crap apples. Blackboard locks me out the drop of a hat. It's really annoying. Okay, so quickly share. So if you scroll down here, not only do you have this stuff in the document itself, but you also have, oh crap, so I didn't actually load it up here. Okay, well let's stop this. And share this. All right, getting there eventually. Okay, so this is the Promega sizing standard. You see here, it gives you all of the different fragments. And here is the Edvitech one, right? So the fragments that you're looking at, just make sure I've got the chat up, are going to be these sizes here along the bottom. Does that make sense? Just as with, so like the largest one will be 6751 will be at the top. Next one will be 3652, or you can round it up as well. It doesn't really matter. Anyway, or if you're looking at the Promega one, you'll get these different size bands. So you're going to measure that. Let's say that's 2 centimeters. I'm just going to stop sharing this so I get bigger. Come on, go away. There you go. Now you're going to plot this. Let's say this is 1, 2, 3, 4, 5, 6. In terms of a scale. So if that's 2 centimeters, you're going to get your first data point for your marker, right? Up here. And then you just keep, then you measure this distance. That's, I don't know, like say 3.1, right? So that's going to be around like so. And then you do that for all of them. You can do that either by hand on that semi-log paper on Blackboard, or, which I'm positive that I did upload. Yeah, phew. Okay. And then the next one might be down here like so, right? So essentially those are the individual distances traveled for each of these bands. And you will get the same for the Edvitech ones, right? But instead being like that high up, you might start like here, like something like that for the Edvitechs instead. It's the same principle applies. It's just the actual sizes of these things is going to be different, but also so should the distances as well. Right, and the aim then, whichever way around you're doing it, if you're doing it as with size as the log, or with a log line, or if you're just doing it by hand, is also good. That's not a very straight line because I'm not very good at drawing straight lines. But if you use a ruler, essentially you want to get it so there's the smallest distance between each data point from your sizing standard and the line for all of them, right? So it's no good doing a line like that, right? Because it's really close to these two, but it's really far from these two, right? That's why it's called a line of best fit. Okay, so this is our standard curve, and the big deal about a standard curve is it allows you to find out values between these points. So that if you have an unknown band which falls between these two sizes, you can figure out fairly accurately how big it is. And so let's say now we have an unknown. Let's say it's, and I don't know how this matches up to the actual gel. It doesn't really matter. The principle's the same. Let's say it looks like that, right? Using the same scale as we did for the other stuff. And now it has this distance traveled is, let's say, 5 centimeters, right? That's the one thing that we do know about it. We don't know its size. And one of the reasons why we don't know its size is because it happens to fall between these two known sizes. So we know it's somewhere in between, but we'd only be able to guess, if we didn't do this, how big it was. And so now what we do, and hopefully this comes back to a question that we had a little earlier, right, is we find that value down here, right? So we know it's moved 5 centimeters. And you can actually draw this. It's easier on paper, obviously, rather than on Excel, but you might be able to do it on Excel too. We draw a line upwards vertically until it hits our standard curve. And you can see, and I did this quite deliberately, it hits the curve between these 2 points. But because this 2 points is like the best fit overall for our entire sizing standard and all of the bands within it, we can be fairly confident that that's a pretty decent line between those 2 points, right, in terms of interpolating the values. And then once we do that, once we hit that standard curve, then we draw a horizontal line to the x-axis, and that gives us, say, (900 base pairs, give or take. And then you're going to have, let's say, a different unknown, right? And so these distances traveled for the unknowns are going to be same for whatever sizing standard you use, but potentially the values you get are going to be different depending on how accurate that line is. Now let's say we get a different band, an unknown again. This might be 2.5 centimeters, let's say, and that's just a guess again. Now we go over here, we find 2.5 on our, sure, that's the x-axis. I always get confused between, on our x-axis or horizontal axis. We draw a line up again until it hits the standard curve. And over here, and that might be 8,500 bases instead, or base pairs, or 8,500. So that's how we go from our one piece of known information, which is distance traveled for our unknown bands, and we then figure out the size, which is the second piece of information, using the standard curves. And so the only kind of slightly laborious part about this, other than measuring lots of distances with a ruler, is you have to do this for both the ProMega sizing standard, the one with lots of bands, and with the Edvitech sizing standard, the one with fewer bands. And I want you to basically compare the values, these values, for these unknowns, between the two different sizing standards, and basically say which one you think is more accurate and why. Hopefully that answered some of your questions. Let me just double check in case it didn't. Let's see. And I'll post this picture up as well. Oh, awesome. I'm glad. I'll post this picture up after lab 2. So another question is, are these unknowns going to end up between these different plotted points? And the question is, the answer is it doesn't matter. because these points, essentially, once you've plotted that straight line, those points are no longer needed because it's the line that matters. And so you could have, another one which is 3 centimeters, let's say, right? And that will go from here, and that will hit down there. I don't know what that would be. If it's log, that's probably going to be about, if this is 8.5, this might be, 4.5. So all we're using is this standard curve is essentially, what it's telling us is for every bit of distance a band moved, its size is this. So if it moves twice as far, then it's half the size, kind of. It's not a linear relationship, which is why this is log. But that's the idea. If it moves, 10 times the distance, then it's going to be maybe 1/10 of the size. But rather than relying on those kind of crude estimates, we use this line, which is a precise representation of the relationship between size and distance, or distance and size. And so if we know one of those bits of information, the distance, we can use this by going up and then across to find out the other bit of information, which is the size. Cool. Awesome sauce. I really enjoy doing this. I like helping people understand stuff. That's kind of part of what it is being a teacher, essentially. What other questions? Let me just double check my email and make sure I've answered. Oh, that was something else. And the big hope, fingers and toes crossed, actually, yeah, just cross my toes, is that WebEx doesn't screw this recording up and put it out of sync. Hopefully. If it does, I'll make one, right, so that it actually it works properly. And I think that's pretty much it. So you just have to make sure that you put down in the actual assignment. Let me go have a look at that. Yeah, so the first two are going to be your graphs, whether they're Excel graphs, JPEGs, pictures of your hand-drawn graphs, as long as you use a ruler, right? Don't draw it freehand. It will look really crappy, and it won't be very accurate. And then it's a simple matter of for each of the unknown fragments, for question 3, you need to enter the distances. You could do this unknown 1, unknown 2, A, B, unknown 3, A, B, C, if that helps. Whatever works for you, as long as I can see what you've done. And then put in the sizes calculated or estimated using the 2 different curves. Pardon me. Actually, you can even just see this yourself. There's no answers here because they're what you calculate. Give me just a second. I was right in the middle of changing when I saw that question. So, yeah, and you can see how much points they're worth, right? So this is essentially all you have to do, right? Graph 1, graph 2, and then enter the different sizes, and then at the end, answer both of these questions, right? Which do you think is the more accurate, and why do you think that standard was more accurate? You could actually say both of them look pretty much the same because they both gave pretty similar answers. That's also fine. And that's pretty much it, really. There's not much more to it than that. Let me get back here. I'm almost positive. So another question was if you'd done a graph before which you're not happy with, or answers that you didn't finish an answer or something like that. You should be able to go back in and change that because the due date has not passed yet. The due date is tonight at midnight. Um, I'm almost 100% positive that that is true. I can't say for 100% positivity because I haven't done it myself. I'm not a student. So if you do have problems with that, which you shouldn't, but if you do, just send those graphs or pictures to me in an email, and I'll be able to use those to put in the correct score. Again, I don't think it will be an issue, but if you do have problems changing the graphs that you've uploaded, then just send them to me in an email before midnight tonight, and then I will use those to grade your assignment. So yeah, don't worry about that. Um, if you have problems, and that goes for pretty much anything, all right, as long as I can see that you've done the work and you've done it before the deadline, uh, you're pretty much good, to be honest. But do try and do it in the Blackboard thing because it just makes my life a little easier, and I don't lose emails or forget or not see them. Um, I think that was pretty much everybody's questions that I got asked privately. Does anybody, and by email, does anybody else have any other questions? It
I have
isn't
a
it?
question, but it's about the homework. It's not about the lab, so I can wait until later.
Okay, I just had another question. It's not letting someone go back in and change anything. Oh, you know what? I know why in that case. Sorry, Alyssa, I'll get back to you in a second. Um, yeah, I know why that is. That's because I've already graded it for you. And I think that's because we're talking about it uh, another time, or am I getting myself confused? Let me just double check. Oh no, that's not the case. Give me just a second, whoever that is. Hmm. Okay. Yeah, I checked and I have not graded yours. Um, so I'm just getting my. I know I've done this for some people because we talked about it separately, but I have not done that for you. Can someone else, just in case that one person isn't causing me grief, can yeah, I saw that one. um, can someone else try and go back into their lab that has submitted it already and just see if you can change anything? Because I can let you go back in, but unfortunately that typically involves you can't do it either. Shit. Why can you not do that? Not as a question to you, that's a more rhetorical question. Like, why would you not be allowed to do that? Um, oh, there are words to be said. And Blackboard, I don't know whoever manages Blackboard, but they sure as shit haven't ever taught anything. Um, Let me double check that.
Mine has the option to try to do it a second time because I think you have like two tries.
Is that
So can you like go in and save the answers that you had already put in there, just like copy them into the text boxes and then try to like submit it a second time because it's letting me try to restart the assignment.
yeah, so try that. Oh, someone doesn't work for someone else. I can also So it's kind of a nuclear option. I can clear the attempt, but that means you have to do it all again from scratch, which I can do. That's not any issue at all, but it does mean that you'll have to, yeah, I know, you'll have to put everything back in again. That's what I mean when I say it's kind of the nuclear option. But give me a second, I'll make sure that it's not. I don't think I screwed up the. Let me check the. Oh, and also I had an update from our Blackboard specialist about looking at exam feedback. Has anybody else tried to check their exam one? I know one of you did and couldn't. Has anybody been successful at seeing their correct and incorrect answers in exam one?
I tried looking at it, but it wouldn't let me look at the correct answers.
Okay. So I've kind of remembered and forget and then remember and forget. Oh, it does work for you. I had an answer back from the Blackboard specialist, which I will send out as an announcement, just in case there's something in that might help. Try it, and if it doesn't help, please let me know, because then I can get back to and say, no, listen, really, I know that's what's supposed to happen, but it isn't happening. And it seems like it varies depending on who you are, which is totally weird. It shouldn't work that way at all. But anyway, let me dig that out. I've got it down here somewhere. Here we go. Because you told me that you should be able to access it, but I know that you should be able to because that's how I set it up. But that doesn't change the fact that some of you can't. Give me just a. All right. Okay. Let's see if this fixes the. There are some bells and whistles and stuff that I can fiddle with in Blackboard that sometimes gives me the desired outcome. It does not always, unfortunately, and it seems to be like a total random affair. 30th of June, that's correct. Okay, so I have changed the options to yeah, so it seems like Gabrielle is special and Angela is not. Sorry, Angela. Okay, so any of you who want to change your lab submission, go and try it now. Oh yeah, retake the exam. That would be fun, wouldn't it? Yeah, try it now. You should now be able to do a second attempt. I think the answer is yes, Angela. I'm afraid. Sorry about that. It seems that once you submit your assignment or whatever, then it's like a done deal. You can't go and change your mind after you've submitted it. But I have opened it up so you can do multiple submissions, right? And I will grade the latest one of those. So give that a shot, Andrew, and see if you can get back in and at least open it up. Good. Oh, cool. Awesome. Right, that seems to be working. So I'll remember to do that in future for other labs. For some reason, it's like, just mystery stuff. Usually multiple attempts applies to each question, but it seems to actually apply to the whole lab as a whole as well, which I never realized. But anyway, another question was, when are the next things due? So if I can spell Thursday. Thursday, what's that? The 1st? 2nd? Come on. Yeah, 2nd. Thursday 2nd equals Excel spreadsheet with graph of linkage data, and use, let me dig out that link. My buddy Dr. Page did a really nice video walkthrough of that. Let me just, that's also in the linkage handout. It does give you now. Oh, good. Well, I'm sorry that you have to do it all over again, Angela. That's not really the intent, but at least you should be able to see your previous submission and then just copy those things over. Hopefully it won't take you too long to do that. Again, you know, it seems kind of a little bit weird, but I guess they have their reasons for doing what they do. Maybe just make everybody's life a little bit more miserable. Oh yeah, good idea. And then just to continue on the due dates thing. Well, I learned that lesson writing a PhD thesis, because you sure as shit don't want to get 400 pages in and then lose everything. What is it? Due Tuesday. What date is that? The 7th? And we will be going over that on Thursday. So if you have any questions about the mini lab report, or even the graph making too, I can help answer those on Thursday lab. Okay. Okay, I think that's everybody's questions answered. It's kind of pending, at least, on the chat. Been very productive. I'm gonna earn my cup of coffee and sitting on the couch this afternoon for sure. Okay, so does anybody have any more questions about the lab due tonight, the standard curve lab? And also, just as a heads up, if you want feedback on your mini lab report, and I'm very happy to do that because it's a big chunk of your grade, as long as you send it to me ideally no later than Monday, I'll be able to get that feedback to you in time for you to A, ask questions on Tuesday, and B, change anything you need to submit the final version by Tuesday evening. Okay, so do make use of that opportunity. I think at least one of you has already, and if that student does what I suggested, and maybe even with more feedback on that, then they should get in the 90s for their grade, right? It's not difficult to do, but you're unlikely to get it first time, just through because it's a practice kind of deal. So yeah, send me those by email. If you send them to me over the weekend, most likely I'll get to them, but I'll get to them by Monday, probably Monday morning at the latest. Right, send them to me Monday, I'll get them to you by Tuesday morning at the latest, if not Monday evening sometime. But we'll also talk about that on Thursday as well. So, Excel spreadsheet, right? This is due this Thursday midnight. Does anybody have any questions about drawing that graph? Again, make use of that video. It's about a half hour long, but Dr. Page takes you through it a step at a time. So really, you just have to copy his motions and what he's doing to draw that graph. And you'll be using that graph in your mini lab report too. So you'll already have done a decent chunk of the work necessary for your lab report. And part of the reason for doing this as an assessment is because making good looking graphs, as you saw from that those papers that I just showed you, it's a useful skill, right? We have to be able to get across complex information in a visually accessible manner as scientists. And so if you don't, or I know some of you are pretty, mean wizard at Excel, probably more than I am, to be honest. But some of you aren't. And so that practice is a very handy thing to have. Okay. Does anybody have any questions? Yeah, I know that you're who I was talking about. Ooh, dinner's being cooked by the smell of it. That's going to be a problem. Anybody have any questions about any of either today's lab or the linkage project? That smells really good, actually. And I've just had my lunch too. Okay, so yeah. That's why I have to cycle so much, because otherwise I'd end up like this 350-pound couch potato that wouldn't be able to move out of his house. I just like food too much. Cool. If anybody, you haven't had lunch? Jesus, I'd be like dead if I hadn't eaten anything in the gap in between. I was about chewing my arm off. If any of you do have questions about either this evening's lab that occurred to you as you do it, or about the Excel spreadsheet for Thursday evening, just send me an email. I will be at least until like 6 o'clock this evening, kind of accessing my email because I've got other stuff to do. And maybe after that, I'll just check in, go and play tennis with my daughter tonight. I'll check in after we get back from that, see if there are any extra emails. But yeah, send me an email and I'll answer it as soon as I can. And let's let Alyssa go have some lunch before she passes out in front of her computer, which would not be a good thing. All right. Well, thanks very much, everybody. I shall see you on Thursday. All right. Catch you later.